Factors affecting the rate of corrosion. Corrosion. Corrosion is a natural process that converts a refined metal into more chemically stable form such as oxide, hydroxide or sulfide. It is gradual destruction of materials by chemical or electrochemical reaction with their environment. Corrosion engineering is a field dedicated to controlling and preventing corrosion. In the most common use of the word, this means electrochemical oxidation of metal in reaction with the oxidant such as oxygen or sulfates. Rusting. The formation of iron oxide is a well-known example of electrochemical corrosion. This type of damage typically produces oxide or salt of the original metal and result in a distinctive orange coloration. Corrosion can also occur in materials other than metals such as ceramics or polymers, although in this context the term degradation is more common. Corrosion degrades the useful properties of materials and structure including strength, appearance and permeability to liquid and gases. Many structural alloys corrode merely from exposure to moisture in air, but the process can strongly affect the exposure to certain substances. Corrosion can be concentrated locally to form a pit or crack, or it can extend across a wide area more or less uniformly, corroding the surface. Because corrosion is a diffusion controlled process, it occurs on exposed surfaces. As a result, methods to reduce the activity of exposed surface, such as passivation and chromite conversion, can increase the material's corrosion resistance. However, some corrosion materials are less visible and less predictable. Here is the map of India showing the corrosion rate. Factors that affect the rate of corrosion. Four elements need to be present for corrosion to occur and collectively referred to as a corrosion cell: an anode, a cathode, a metallic conductor, and an electrolyte. Changing the potency of an electrolyte affects the rate of corrosion. Corrosion rates are determined by a variety of factors. However, five factors do play an overwhelming important role in determining corrosion rate. Oxygen. Like water, oxygen increases the rate of corrosion. Corrosion can take place in an oxygen deficient environment, but the rate of the corrosion reaction is generally much smaller. In immersed condition, if electrolyte is in contact with one area of metal containing more oxygen than the electrolyte in contact with another area of metal, the higher oxygen concentration area is cathodic relative to the remaining surface. An oxygen concentration cell then forms which result in a rapid corrosion. Temperature. Corrosion reactions are electrochemical in nature and usually accelerated with increasing temperature. Therefore, corrosion proceeds faster in warmer environment than in cooler ones. Chemical salts. Chemical salts increases the rate of corrosion by increasing the efficiency of the electrolyte. The most common chemical salt is sodium chloride, a major element of seawater. Sodium chloride deposited on atmospherically exposed surface also act as a hygroscopic material, which then increases the corrosion in non-immersed area. Humidity. Humidity and time of wetness play a large role in promoting and accelerating corrosion rate. Time of wetness refers to the length of time an atmospherically exposed surface has sufficient moisture to support the corrosion process. The wetter the environment, the more corrosion is likely to occur. Pollution, acid rain, and chlorides promotes a corrosion. Acid rain, such as carbon dioxide, can also dissolve in a film of moisture in contact with metal. Conclusion. Protective coating can control one of these elements, that of the electrolyte. Applying a tightly adhered continuous protective film over the surface of metal, we can control rate of corrosion or eliminate it altogether. Working with a coating professional, you can identify the specific corrosion control need of your infrastructure and select the appropriate coating that will best serve your business. Thank you. Thank you.